Hi, it's Gadget UK here again. Yeah, this video we're going to be reclaiming some of the parts off here. A boring video really, but well, not what it leads to. In order to get the parts onto this. Yeah, so things may appear out of sequence because I've shared this stuff already and more of this yet to come on early access for Patreon and YouTube members. So yeah, I apologise in advance if things seem out of sequence. But we've got a 1000 case. You saw that blue bud there, that's for a 1000. It's a remake. Some bits and pieces, as I say, we'll come back to this in another part. So this board kindly came from Conrad Larson over in Australia, I think. Was it New Zealand? It might be New Zealand. I always get the two mixed up. But thanks to Conrad, and this is one of the reasons why, if you saw my recent 2000 and 1200 repairs I did for him, I didn't charge him anything other than just the shipping. The shipping was a bit expensive, but I spent considerable time on both those boards. And I did that because I felt like I owed him really, because he sent me this just as a gift, said, Chris, I've sent you some boards, I hope that you can use them, I'm not going to be able to build them. And I think Conrad has some, sort of long-term health issues, a bit like myself, but, maybe, well, definitely worse than my health issues. And I know that because I've been chasing him since he got the 2000 back to say, how are you getting on with that board? Is it alright? It's like, my health's not great at the moment. And he's not had a chance to even look at them. So I'm wishing you all the best, Conrad. I hope you're getting better. I hope this video series here cheers you up and stuff to see these boards come to life. Now, in an ideal world, I would get all this together and send it off to him. But yeah, the cost of all the parts and the time, it's going to take me considerable time to build this board. And the cost of the parts is just nuts, absolutely crazy. I'd spent something like £300 on parts before I even got the case. And the case is still on my credit card. I bought that case 12 to 18 months ago, and it's still on the credit card. It's like I'm paying like the minimum amount of like £5 a month or something, and the interest is like £3 a month. It's like it's not changed. So the bottom line is, like I said, if I was a huge channel making lots and lots of money, I would build this and send this off to Conrad. But yeah, I can't do that. It's cost me an insane amount of money for the parts for this. I'll talk more about that as we proceed through this series. But just to be clear, we did say, I want you to have these because I'm not going to be able to build them. There's too much time, too much cost, etc. So this board was produced by George Braun in Germany, I think, and it was on the back of an A1K forum posting. I think there was a PCB in the past called Phoenix, which I think that brought an 030 card, didn't it, or something to one of the Amigas, maybe the original Amiga 1000. And basically it was an attempt to, take that and actually build it into a motherboard. But it merges in the AT bus card, IDE. It takes Amber from the Amiga 3000 to give you a scan doubler. It upgrades the Agnes because the Agnes was extremely limited in the original Amiga 1000. So you can put the 8375 on this board and have 2 megabytes of chip RAM. It provides a flash ROM of up to a meg in size. I'll talk more about that again as we proceed through this series here. It provides 8 megabytes of Zorro 2 RAM. And yeah, it's just like a remake of the footprint of the Amiga 1000 motherboard. But it's far from an Amiga 1000. And it's important to note that I would not go out my way to sacrifice an Amiga 1000 by taking its motherboard out and fitting something like this. If you've got a broken Amiga 1000 motherboard, maybe where the Agnes has died or something, yeah, this is a good use case. Take your original board out, maybe sell it for spares, or keep it, and for one day you might be able to get a replacement Agnes or something like that, and fit something like this maybe. Now, my original plans were to fit this on the bench and just have it as a test board, but then when I saw an Amiga 1000 case come up in a pretty beat up state that had been completely stripped for parts, and even its motherboard had been stripped and sold off separately, I couldn't obtain a motherboard, so I thought, well, why not buy that case and home it in that case? Yeah, and the rest is history. So here we are starting this build here. It's going to be a number of parts to this because there's a lot to do. But a massive thanks to Conrad for sending me this board and the smaller sub-boards, which you'll see as we get later into the series, that go with it. This obviously has an 030 on it and a 68882 FPU as well, clocked at 50 megahertz. So this is like the Terrible Fire before the Terrible Fire, and obviously implemented a completely different way. It uses a lattice chip and a load of GALs. The 536 in this day and age obviously is a much sexier implementation of 030 with far fewer parts, easier to program, easier to source, although those Xilinx CPLDs are about to become obsolete. Anyway, massive thanks to Conrad, and a huge thanks to George Braun for producing this board. And as a side note, and we'll touch upon this in future videos as well, there's a few different revisions of this board. There's a Rev 0, a Rev 1, a Rev 4, of which my board is a Rev 4, and then there was a Rev 5. And the Rev 5 just took all the corrections up to the Rev 4, and then added in the 040/060 as the default CPU on board. So it kind of merged the TK1000, was it? I don't know, the 060 card with the motherboard. So this is the last of the 030 supporting revisions of the GBA 1000. There'll be a link down below. You can see on this website here, you can actually buy these boards still. There's a place in Poland that you can purchase them from. So yeah, take a look there, and you can see the 060 card there as well, and the graphics card too. But right now, the focus of this video is to get as much off here as I can for that board. Yeah, so I will cover putting these parts on in this video, I think. Yeah, I'm just going to use the desolder pump. I'm not going to use the desolder station. I'm just going to switch the iron on. Well, we've got some flux here if we need it, but hopefully we shouldn't need that. I'm going to bring this over here. Yeah, and we'll leave this large tip on here just because it's going to pass the heat pretty well. I'm going to start with the ROM socket here, actually, I think. Hang on. Yeah, there's no pin. that top one there. It's the socket that accommodates the 1 meg chip, despite the fact the 1 meg chip isn't used. Yeah, and I'm just going to go around that way. So expect some fast forward montages. And doing something like this is good practice for you to soldering as well, by the way. So if you've never done much desoldering, consider getting something like this that is absolutely beyond. Yeah, and this one is. The other thing to consider here as well, you could say this is sacrilege, destroying a 500 plus board, but all of the parts have been taken off it, and all of the parts have been taken off hundreds or thousands of boards like this. So there are far more boards around that could be saved versus the number of parts to populate the boards. Yeah, so that's where it kind of does make sense to strip some of these boards down for spares. You could argue most of the things on my channel should have been scrapped and used for parts, really. Well, some of them, the 500 plus maybe from RRG. Anyway, we've done the solder points on one side there. It's, they're a bit dull. The pins are a bit dull, but they're not corroded. These ones up here are, because, look at that, it suffered a bit of an ouchie there, hasn't it? It really has. It's a bit sick in that area. But that could probably be repaired. You could put a new socket on here, someone has had a go at scratching, this all off with a grinding pen or fiberglass pen or sandpaper or something. But ultimately, yeah, it's just not worth it. Yeah, but anyway, I'm going to reclaim those ones. We're going to stick those into that new board. I am going to take that off because it's dual wipe. So that'll be saving that. We've got a load of RAM here. We can test that, perhaps in this video. We've got the hybrid. And then we've got each of these connectors here. So we've got the video connector, power connector, serial parallel, forget which one's which. That's the external floppy drive, actually, and then serial parallel. The audio connectors I can't use on this other build I'm doing, but the controller connectors here, joystick, mouse, we can. And then I'm going to take off as many of the passives and things as I can, including these here, the 1488, 1489, 74 series. Yeah, we'll just get off this as much as we possibly can, if not everything, including resistor arrays. I need the crystal as well. That's a key part I need for that other build. Yeah, I just need to do this solder point here, and it's it's on a power rail, I think. So I'm just going to crank the temperature up by 40 degrees. So instead of 405, I'm at 445. Just waiting for it to heat up. Get some more solder onto that. I may get the 68K socket off next, even though we don't need it. Not for the build I'm doing. There we go, completely unblocked with one go. So that's the difference an extra, 20, 30, 40 degrees can make. So I'll put the temperature back down to 405. 405 with a Heiko that I use is a good temperature to go with these. And if I was repairing this, you could argue it makes more sense for me to use the desolder pump here from Andrew Littleboy rather than the desolder station. As you know, it's an Anici ZD915, it's a Duratool clone. There's much newer models of that sort of series now that are better, probably. But nevertheless, the nozzle, even though I've got the smallest nozzle on it, it would normally mark the traces here, and I don't think we'll have done that. despite the fact we're not bothered about the board anyway. But you see what I mean? It's all about practice. You can practice your desoldering skills by spending the additional time to use, you know, a manual desolder pump and just go at it the old way, really. So that's mostly free now. Again, we're not bothered if we damage the PCB. Well, that side's off. One or two of these pins are going to need retention, and I can see that one there is squashed inwards a bit. And one or two of the pins may need replacing, to be honest. It's one of those. Under magnification, you can give them the flick test like this. Any that don't ping, you know, are not free. Like that one. Oh no, it's free. Well, seemingly they're all free. I don't know, maybe it's just going to come up. Yeah, there we go. Yeah, so no damage to the board. And we've got our socket off. So I could use a little bit of braid to remove the solder on those, but what I'll probably do is just push out that one pin where it's a bit squished, can you see there? And retension it, but then I'll soak it in the ultrasonic. Yeah, some of the pins down here are a bit green, actually, but anyway, trust me, I will reuse that. Maybe on that other board, but the one we're building. Right, that's that off. I'm going to get that off. This is destroyed, so there's no point in that. I'll get the crystal off next, and then we'll get that off. Crystal is obviously a key part we need for that other Amiga board. Can't even see where the solder points are here. And this is going to need soldering straight on. The legs are going to be short on it. I wouldn't put it in the socket. It's the right speed, I think. And that's an interesting point. I'll show you in a minute on that board. There's a typo on it, on the silk screen. I'm going to need more heat for that one. And I might need more heat for this one, let's just see. It's like that side's up. The other side isn't. What I don't want to do is break pins off the crystal. So let's just heat and pull. That's it. So, yeah, all of our legs are intact there. Yeah, so 28.37516. The interesting thing is, the point down here it says 28.735. That's not right, that's a typo, I think, on that silk screen. So, let's get that crystal on that. Yeah, that's correct. So just checking it's the right way around it is. Yeah, some people might want to socket that, but, well, I don't see it ever failing, unless it's already failed. There we go. It's technically that's the second component soldered on because, well, third, because I already soldered those in a different video. This is just sat in place. Right, so for some of these I am going to use the desolder station. I've got the desolder station set a bit higher, and it takes ages to heat up that desolder station. But I will continue to do most of the work with this. And we may need to free the odd thing up on here with some hot air. Let's just see if that's anywhere near the temperature here. I can hear it sucking, but is it sucking in a good way, or does it suck? Oh, that's working well. There we go, so I'll just go over these once over. Well, let's try and get the hybrid off just using the desolder station here. Yeah, I just destroyed one of the resistor arrays there. I'm not fussed about really, but still it would have been nice to get it off. Yeah, these are just not desoldering very well. This is the thing, I'm going to switch the desolder station off. I just find that desolder station is awful. Yeah, strictly speaking I should clean the inside of that, but I'm not going to bother. I'm just going to squirt some WD-40 inside it. And that should make it suck better. And it's so much better than the desolder station as well. This is the thing. I really miss my welder. I used to have that welder, DS801 I think it was. God, that was an amazing piece of kit. Now, I took one of these hybrids off recently on another video, and I got it off okay, but this one, yeah, I'm not sure it's going to come off easy. I'm going to try and free this up with hot air. Right, I'll show you how I got that off in a minute. It was not too bad actually, but it did take a few minutes. So I'm going to solder this straight on actually. We'll start with the anchor points. So this is the external floppy drive connector, I think. Or is it the video? Oh, it's the video. This is the video connector. Yeah, it's 23 pin. Having said that, isn't the external floppy drive similar sort of size? I can't honestly remember. I think it is. So just making sure that's nice and flat there. I'll inspect it from the other side before we solder any of the other points. Yeah, there we go. So the pins look good there. And that is nice and flat and flush. And we've got a little bit of solder up there. We can add a bit more. This is the thing. If you add a bit more, obviously it anchors a bit better on the top side. But we'll do that after we've soldered these points. So now it's flat. I'm just going to solder these other points. There we go, that's not too bad. Yeah, cleaning up as I go along here. It feels incredible to start building this board, to be fair. It's been sat around for 18 months, I think, at least. 2 years. In fact, 2 years, at least 2 years. Potentially 3. I think this came sometime in COVID. Well, it probably doesn't make sense to put things like this on first, but I just want to do it. I want to have a sense of achievement. I want to see it looking more and more and more like a board, a real board, a popular board. Right, I'll have a toothbrush around that. And despite the craziness of it, I am going to mask there because, well, it's just keeps it cleaner. Yeah, there we go. One port's down, the video port. It's looking pretty complete, isn't it? Yeah, so I've continued to use a higher temperature here. I'm using 440 on the Heiko just to solder the points there. I'll just give that a slight pivot, not a lot. Again, we're not bothered about damaging the PCB. Use desolder braid there on the anchor points. Give those a little pivot as well. Those are the main things that are hard to get off on something like this because, well, the heat sink in the ground does anyway. Yeah, have a bit of a wobble like that. You can see many of those are free, if not all of them. Let me just get the magnifier. Yeah, I can see all but this one here, so I'm going to wobble it as I heat that. Then I'm going to use the solder pump on it. That's on the ground, so I need to leave it for ages. There we go. Wobble it. Right, that one's now free. Now there's one up here on the left. Yeah, the first one up here. Yeah, just move the camera down a bit there. This one up here is the same. So I just heat it and a wobble. So you see it moving. You may pull off actually at this point, because I think that's the only thing holding it. Yeah, I think what I'm going to do here now is heat it with hot air again. It's just here now. There we go. It's off. And no damage to the connector. Probably no damage to the board. Although, because we use 440 degrees, it's really easy to mark the, to damage the actual fiberglass. Yeah, that's perfect. That is perfect. And of course, you could source new parts for the parallel serial. I don't think there's anything specific, make these unique, really. That looks like a standard DB25 female port to me. Anyway, we'll get that straight onto the other board. But you can see we're making some progress. We've got rid of the hybrid, we've got rid of the video connector, I removed the choke, the power connector. Those are going to be used for something else, I think. And then we've just removed that there. No damaged pads or anything there, just a bit of a sticky out solder. We're getting there. I thought these were going to be the worst, but yeah, I'm not doing too bad here. Yeah, and you could argue clean these up before you start. Now, F25, female 23, male 25. Yeah, so that's female 25, isn't it? Yeah, there we go. It's going to fit nicely. This is probably the point where I stick the wrong port on the back. I don't know, we're sticking them in the same order they were though, aren't we? So, that's got to be right. Yeah, you never saw me do the other one. I'm sort of got a drag solder here. So I'm going to, hang on, copious, if I can get that solder in the right place. Copious amounts of solder and sort of slide along like this. There we go, that's not so bad, is it? And there we go, that's 2 ports on. Yeah, I'd like to say there's method to my madness here of doing things in this order. But, well, yeah, there is. I want to get rid of that 500 plus board. And if we get all these connectors on, then it's just something out of the way, isn't it? Because there's so much to do on this. It's going to take me ages to build this. It's all these little small things that are going to take most of the time, you know, the sockets, and that's what I'm going to follow on with, the sockets. I'm going to finish off with the small stuff, I think. You can argue do the small stuff first, but I never struggle, even if the board doesn't sit level on the bench. I'm going to be able to get all these little caps and things on, it's not going to be a problem. I've ordered some sockets for here as well. I've got one, I've got red one, so sorry, a white one. I've ordered the red one and the yellow one. It's going to go there, composite, left-right audio. That's that DIN, isn't it? That's going to be soldered on another video. Right, on to the last port here now, the floppy drive port. So yeah, 440 degrees. It's pretty high, a big tip. Yeah, suck up the solder with this. Use the braid. Finally there in a minute when we've got all the remaining solder off. On the anchor points, that is. They come off pretty easy, these though, certainly with the Heiko. The Heiko came from Dermot Swing, by the way. I don't always mention that. I talk about the Heiko a lot, like let's use the Heiko, and then I forget to mention that it came from Dermot, and I'm always thinking about it. What isn't moving is this right hand side point on the right hand anchor. That might have done it. I saw some solder get removed there. Yeah, that's it. That is now free. And I can feel the port is a lot looser. So what I will typically do here, bear in mind we're not repairing this. We are just trying to get this off. I will get a screwdriver under here and then lever up like that. Over here, try and lift it a little bit and then get under it. There we go, off. No damage there at all, no through hole or anything. Yeah, so that one's going to go there. That says M25. This one says F23, so that's female, and it's 23 pin. So let's just try and line that. There we go. They go on really easy. As you can imagine they would really, because, well, as long as they've not been manhandled, and these haven't. Yeah, I think that's it. Yeah, that's not so bad at all. So we'll just get that final port on now. I'm so pleased to be done with these things. We'll obviously get the serial parallel dongles into these things later to test it if we get the board working. I say when we get the board working, I don't know, I've not got a high level of confidence that this is going to work when I've done it. And that might come across as a bit of a surprise really, why would I not have confidence? And it's because, well, there's so little information on this board. I mean, I've got the JEDEX, I don't know whether they're the right ones or not. I don't know if there are any revisions required to this board. I don't know whether the board was revised or mods required to it. I honestly do not know. I don't even think I've got a set of instructions for the jumpers. So that's gonna be a bit of an interesting one. It was created by George Braun, I think, Braun. Hence the GB in the GBA 1000. So it's a George Braun A1000 effectively. I don't know how stable it's going to be either. Because, well, I haven't seen anybody with one of these. I've seen a couple of blogs, one blog I think where someone built one, didn't really complete the blog. I don't know whether it ever was finished, whether it works at the end or not, what problems he may have had. It was the last update in the blog was like, I don't know, 2000 and something, 7 or something. Yeah, just inspecting the pins there. They're all nice and straight. So I can commit to soldering that one on as well, I think. And there we go. So I'm going to squash the cotton bud. Yeah, we've taken the time to do this, so let's just clean with some deoxit. Very carefully, you can sort of squish in, squish out. I will need to inspect with magnification in a minute, make sure I've got no cotton fibres in there, because one or two may get stuck in. I can just pull them out with the tweezers. They're gold plated and they seem good as new. Bear in mind, on one of these ports, and maybe this one, we had straightened a couple of the pins. It was the corner pins. Anyway, you can see the bit of dirt that's come off that. Yeah, there is a cotton fibre in the middle there somewhere. We'll do the same thing over here. I'll just spray some contact cleaner into those ones. Looking good as new now, if I'm honest. Yeah, so same thing I've done a million times before on my channel. Bit of flux on some braid, using the pliers as a vice here, just like support on the left hand side with the magnifier here, and then I'm just going to heat over the pins here and just absorb the excess solder. Clean up with a toothbrush and some IPA. I always spectacularly make a mess when I'm doing this. Anyway, you can see the pins on that. Oh, excellent. Just need to just flatten them a little bit now because they're not going to be very straight. So I use the thin nose, needle nose pliers here. And I just rotate, you know, upwards, like, not really rotate, but move upwards like that, up them as I squash a number of times. And inspect that orientation. You can see this pin here has been bent at factory to support it in the board, you know, to anchor it kind of thing. So I'll just squeeze to the left just marginally, and then go back that way again, just because sometimes you can alter the angle when you're not you're trying to do it in that angle, if you see what I mean, the other orientation. It might not fit in here very well because the legs are very short, but anyway, that's done the job, I think. So yeah, that's pretty good. That should go into a turn pin socket nicely. That is the 1489. So we'll do the 1488 next, I think. Is that one? Yeah, that's that one. You can see there's quite a lot of solder. You can see it builds up all around the pins at the bottom, the base, and you get it all over the tops there. This looks awful. So I'm going to remove the real-time clock chip now. I've desoldered as much of the solder as I can from there using the engineer desolder pump from Andrew Little Boy. Get this extractor thing just on the dip chip there, and sort of just pull down while we heat here. I wouldn't normally be perhaps this ferocious, you know, this aggressive if I was going to repair this board. There we go, so all pins are intact. Yeah, so in terms of what else would I take off this, I'll take all these little caps. I may even take the resistors off it as well. The 7.4 series, all of the RAM, we'll test that RAM, see what works, what doesn't. Even the resistor packs, well, everything really. The only thing I wouldn't reuse really, I think, are these. I mean, we did come across one of these where someone had trimmed them or something, hadn't they? And then they had to resolder them, but yeah, they're not that great actually. You know, they're just metal. Yeah, but I think you'll agree it was a good decision to scrap this spares board here, because I mean, look how corroded those are. It's unusual to get corrosion there. You know, you can see how bad it was there as well. But we'll also get that off and that off, but that's going to go in the bin, I think, because it's a bit greener. I might keep the carrier and repin it. Best advice I can give you when you try to salvage components from here is excluding things with plastic on, like sockets and things. The best thing to do with those is do what I did, you know, straighten the pins, desolder them as much as you can, use braid, wobble them until eventually they come off. Otherwise you'll damage them. But when it comes to like resistors and caps and the resistor arrays, they just disintegrate. I've tried taking 3 off with hot air so far, and a pin always just comes out, even though the pins are all freed up, and they're just really hard to get off, those resistor arrays. And I've had that with every one of these I've done in the past. I mean, it's different when you try and repair it, because you take it a lot longer, and you can get things off carefully. But when it comes to everything else, like ICs and things like that, and these things here, which I'm doing next, I'm taking some of these off, not all of them, because there's no way I've got the patience to take every single one of these things off this. But you can see I've got most stuff off this board. I'm going to take the remaining chips off. I'm going to do that in a minute. But the way to do it is to straighten the pins. Let me do these ones up here for the lost where they are now. Yeah, these 4 here. So you may need to crank up the iron temperature, add some solder. Yeah, it's like just the way they've been assembled. They bend the pins to hold them in the board before they're soldered. It's so annoying. This is why I never bend component legs when I'm building something myself. It just makes it easier to rework later. But anyway, if you straighten these up, and then they will come off with hot air. Yeah, I just remembered the approach I want here with these is underneath. Resistors I tend to heat from the top, just actually heat the leg, and you can usually get them off pretty easy. Just occasionally just touching it to see if it starts to wobble sideways with literally no pressure, I know it's free. But if the legs are not straight, you won't get it off. So it's starting to move a little bit. There we go, look, it's free. 1. I tried to take these off before when the legs weren't free, and it was impossible. You've got to use quite a lot of force to try and straighten legs as you pull it, that's the issue. Yeah, 2. This is the last RAM chip, so I did these in 2 batches of 4. Just for my sanity really, they're just so fiddly to get off those boards. Right, back with the Rev 6A board that we fixed in a previous video, link top right. It's fixed twice actually, and this board last featured in the Spitfire 500, switch it on. And it's a good test because, as you can see, I'm testing out the plate for the GBA 1000. Yeah, just making sure it is actually working. But the reason I'm using this is because we've got an memory expansion here that uses the RAM that you get on a 500 plus or a Rev 6 2000. Let's get this RAM out. One of these was replaced because, well, one of them died. I'm trying to get the flat blade. Yeah, I've got to stop using that pointy tool for removing ICs, because when you use a flat blade, you get flat under the edge and you do a lot less damage to the actual socket. You know, you get little marks, round marks, if you use something that's too thin. If you get something that's flat like that, you can just get the leverage you need and you won't mark the socket. So let's get all 4 of these off. Pin 1's at the bottom here, so gotta hope I've got rid of all the solder here, otherwise they might damage the sockets. That's right, let's just do test all. So it's going to be testing the onboard memory as well here as a result of that, but anyway, if we get any failures, it's going to be in that RAM we're testing here. Yay! Yeah, so I've got 512k there, 512k here, and it's just tested the full 1 meg. It's on round 3 now. So yeah, those first 4 chips there are all good. Right, that's all 4 in. Pin 1, pin 1, pin 1, pin 1 at the bottom. Fingers on it, ready for the temperature check. So far, this is looking promising. 1 meg, test all. Generally, if it passes like, you know, 3, 4, 5 passes like this, and it doesn't get warm or hot, it's going to be fine. So I can power that off, remove those, put all those away, mark those ones up as well, and write in OK on it. So it's worth pointing out that, you know, different speeds, these RAMs, not just different part numbers from different manufacturers and things, but different speeds. The ones there, -80, even that one is the same make as those, but the label's a bit worn, and it's a -80. It's a Toshiba, yeah, TC514256A. These ones here on the motherboard, these are -70, the Siemens, the same as the ones we've just recovered. And the part number of those is HYB514256A. The ones we've reclaimed here, those are Hitachi. I thought they were Siemens, they're not, they're Hitachi. Hitachi ones are better, if you ask me, than Siemens. The Siemens ones do occasionally die, hence why one of mine on my 500 Plus died, and I've had them on one or two other things dying, just the odd one. Yeah, so these Hitachi ones are HM514256AP-10. So these are going to be 100 nanoseconds. So, and this is the thing, you're thinking 70s, 100s, you can put either of these on a 500 or 500 Plus. And of course on this board here, we didn't necessarily need to use this expansion, because the Rev 6A has got sockets for the additional chip RAM, and I fitted these previously and the caps to go with them. They're not exactly the right style of caps, but they're the right size. So we could have just changed the jumpers. I think it's JP7A and maybe one up there, and the CPU JP3 is it. And you can have 1 mega chip on board, but then that kind of makes this slot defunct on this board without further modifications, I think, because you've not got any address decoding or anything, you know, for the additional, you know, to be able to address anything else really. Anyway, so those are all marked up okay, the -10s. But the other thing here, you know, we've got 2 different speeds already. Got some more here that I got for Cather's A3000, and these are -60s. So these are Siemens ones again, HYB514256B-60. So, yeah, we've got 60s, 70s, 80s, 100s. And any of those will work on here. The 3000 might be a bit more picky, because of, well, maybe not, I don't know, because it's just chip RAM at the end of the day. I suspect the -100s would work on a 3000, but anyway, yeah, I've got lots of different speeds there. Yeah, so I'm about to get these chips off here. I'll just show you what I've been doing here. Not even adding solder and flux, just heat and, hang on, push, that one's straight. The ground and VCC are always harder. You don't need to push as hard with the other pins. See, that's straight, just like straightening them up, leaving the solder on. So loads of solder on those, you know, I've not desoldered them at all. So if you're removing this to repair this, you wouldn't be using all this heat like this, you would remove all the solder. And then it would come off really easy. You'd have a lot less airflow, a lot less temperature, and you can get it off without marking or delaminating, etc. Here, I don't care. It's just stuck here somewhere, there we go. Yeah, and the pins are straight on that, so just put that carefully, pin face down, and move on to the next one. Right, that's it, I'm done. So technically, yeah, I could salvage that, but I mean, I've got loads of those. Look in the pile, I've got about 20 of them or something. So, and that got mangled. It's just, you know, it's really hard to desolder that. These just break. I don't see any point trying to get those off. And I have got most of these filters off. There's just the odd one, and you've got to straighten the pins individually on every one before you try and use hot air. You know, there's a batch here, but I got rid of loads. There's loads have come off it. These just, you know, fragmented ones around the corrosion area. The stuff around here, I'm not interested in corrosion. These caps I'm not bothered about. Again, corrosion, broken, caps are all crap, the electrolytics that is. And again, these just break. I mean, I could spend some time with the desolder station desoldering these. The pennies. And I've got packs of these, so I really don't see any point. And I actually didn't damage a single connection. I even removed these. I didn't think that was something I was going to do, but they came off really, really easy, so I figured, why not? Yeah, every one of these resistors is okay so far. 47 ohms. I'm sorting these in my, I've got generic trays here for resistors, for these resistors. You know, odds and ends. And if I need something specific, I could go hunting through my trays, and it takes me ages. Anyway, it's the only way to store them when you've not got like tons and tons of wall mounted drawers, and I've got nowhere to put any more, so 5 ohms. Yeah, everything is okay so far. I mean, that was a 4.7 ohm, it was measuring 5. Got loads of 10Ks so far. That's a 10K. Yeah, I have a bag specifically for 10Ks here. Right, let's go test all those in the TL866. I'll put the 555 directly in its little component tray, because I can't really test that way. But 7.4 series you can test on the TL866. Yes, those all tested out alright. The first error was me just leaving it on the wrong 7.4 series and putting a different one in, just to make sure it did actually fail, and it did. And then the second one, the pin was misaligned, and then it was alright. So everything tested out okay there, so I'm just going to mark these up. Just bear in mind, the 7.4 series testers and the TL866, they're not a panacea, you know, they're not going to solve all your problems. In other words, I've seen evidence myself of the 7.4 series test passing when a chip has got an issue. You know, its logic level is not quite right. And that's the thing. It's detecting the highs and lows approximately, you know, with the threshold there. What it's not doing is testing the difference between a CMOS and TTL on inputs and outputs. It's not testing the speed of the device, yeah, in other words the timing, how fast the transition is, slew rates and things like that may be there in a fault. It's just going, you know, is there a high on the output when I'm putting X, Y, Z on these inputs, etc. And yeah, it doesn't cover all bases. So yeah, just bear that in mind. Right, anyway, I'm going to put those away. So all those other components have been put away now. All the resistors, all the caps, all the filters. The sockets are in the ultrasonic cleaner still. I straightened all the pins on them and removed the solder, and then just put them in the ultrasonic cleaner. So I'll get those out in a minute and put those on the spares as well. But the final thing here is this power socket. There was corrosion, really greeny, all on the front here, all on the underside here. You can see it's almost gone coppery there because I've used the fiberglass pen on it. But I figure because I've done that, I'm just going to get some flux on here and I'm going to solder over it, because otherwise it's just going to corrode again probably. I got a spare one of these from Sparks UK, which I desperately need to replace my other one, my 1200. So I'll use the one Barry sent me for my 1200, and this will just go into my spares for something else. If Barry is short one of these, you can always let me know, Barry, and I'll send you this one if you're absolutely desperate for one of these. But I mean, at least I've got a spare now. But I'm quite happy to send this one to Barry if he wants one, because I'm very grateful for him sending the one that I can stick on my 1200. But you can see it's not too bad. It's a bit grey down here, and it is a bit sort of oxidised under there. But anyway, the corrosion's all gone on that. Internally it's okay. The next thing I need to do is test this complete set of chips here for an Amiga. So you can see we've got an 8371, that's the same as on this Rev 6 board here. Originally it would have shipped with an 8372. It's worth watching the repair of that video, there'll be a link top right. So yeah, we've got one of everything here, I think. We just need to test them. So yeah, without further ado, I think I'll just remove everything and we'll change the whole lot over. Just a quick test first, just to make sure it is still working, and it is. So wrist strap on, we'll start over here. That might be a kickstart 1.2. Pin 1 is at the top there on that one. Just check the pins again. And I think we'll try it actually at that stage, because then we're just testing a couple of chips at a time, aren't we? Yep, that's a good sign. So at least the CPU and kickstart work okay. Yeah, it's 1.3 actually, that's alright. Quite like having a 1.3. So I think I'll leave that 1.3 on this board. It makes more sense than having a 2.04 or whatever it is, or 2.5. Right, anyway, so we'll just squeeze with the PLCC extractor again and gently lift. So that's the 8371 out, looks good. And we'll get this 8371 in. So the shaved edges are there, which corresponds with this top right point here, and it says pin 1 there in the middle of the socket, and on here there's a little dot, can you see that? That's pin 1, so it goes there. Make sure it's in the position, you know, on all four sides first, then just push down, and we'll try that. Yep, that appears to be working. Obviously, you want to do more tests, but I mean, once I've got all these chips in there, I'll boot some games from floppy and stuff and run this check. That chip is proving to be impossible to get out. It's like, can't get under it at all. There we go. Just on the edge. Just on the edge I managed to get under it a little bit. Oh, wow, that's in there firm. And of course we can't get over this side now because the blooming shielding. Are the nuts in there? No, they're not. Some of them maybe. Yeah. If you struggle, just remove the blooming shield. It's far easier. A little bit of a bend there on that pin. Yeah, they're a bit squished in this. I remember some of these being like that when I got those. Alright, so that was the 8362, which is Denise. And we got that one there. Again, the pins look immaculate on that. And pin 1 on Denise is on the right side there. So let's get Denise in. Really firm. Yep, all okay so far. So I'll switch it off again. Let's get Paul out next. It's easy because you can lever from there a little bit. This side, however, you need to be a bit careful because of the caps and things here. But you push it back down, there we go, it sort of seesaws a little bit, and then we can get that out. So, yeah, that's one of those ones where, this is one of those ones where the pins are a bit squished in. Anyway, that's Paul out. So Paul is 8364R7. Now, if you saw a previous video, I've got loads of CIAs, so I didn't actually need the CIAs, but I managed to get this full set of chips for around the £50 mark, which is a lot of money, but it's a pretty good value, really. You'll pay 20 quid or more each for a CIA these days, so yeah, I just see that as a positive, really. And we'll swap Gary as well at the same time, I think. Let's get Gary out. Yeah, those are still looking a bit greeny there. More cleanup as that is required. Anyway, let's get Gary in. The socket pins are fine. Just like I said, it wasn't this board where those corroded. It would have been a 500 plus, so yeah, pin 1 to the right. I'm going to test it like that, and then we'll just get the CIAs in. Woohoo! So, we're onto the CIAs. And go, power off again. So, if you've never worked on an Amiga before, you know, I'm sure you've gathered by now, everything's socketed. Yeah, apart from the RAM and the data path stuff and some of the 7.4 series. So, yeah, they're a joy to work on 500s because you can just take some known good working chips and very easily chip swap to work out what's what if you're not familiar with the system. Yeah, these are CIA's complex interface adapters. They're like the pretty much identical to the 6526 you get on a C64. Can't get that side out at all. It won't. Screwdriver will not go under. Really struggling again. These CIA sockets are really stiff compared to anything else on here. What I can do is try and get a bit of leverage that way, there, like that. Yeah, there we go. You tend to find that a screwdriver will mark these sockets, you know, you get marks there. Anyway, that's the two CIAs out. Let's get these two CIAs in. Wrist strap's still on. You'd be foolish to handle these CIAs without a wrist strap, trust me. Yeah, so pin 1 towards the right. That's a good firm fit. And again, inspect the pins, pin 1 towards the right. Yeah, so these chips will live in here forever and a day now, I think. So this time I've got the floppy drive connected that we fixed in the previous video. Let's get the mouse while it's booting. Oh, that's not booting. Ah, the disc's not in. Oh, yeah, how else have you got the disc in? I'll put the disc in. I thought for a minute we had a CIA problem there related to that floppy drive. Yeah, there we go. So let's just have a look at everything here. Let's do a quick memory test. It's worth doing things like that just to make sure the Agnes is okay. Oh, we've got an error there, look. That's weird. Could be a glitchy Agnes here. Could have been sold a glitchy Agnes. Same place, look. Same place. So, I don't know, maybe it's RAM. I think what I'm going to do is just remove the RAM expansion and test without it. Now, I do know that this was making a bad connection at some point with one of the other boards and giving a bad, you know, RAM error. And, just, oh, there you go, that was a bit loose. Just pressing those down may solve it. Let's just try it without that, just make sure we don't get the error. It's probably going to be that socket there. You heard a bit of chip creep there. Chip creep is the name referred to when you know a chip creeps out of its socket, usually from thermal cycling. So, you know, the words hot and cold cycles, you powering it off and on, off and on, off and on for weeks and months and years. Chips can eventually slide slowly out the sockets or creep out the sockets. Look, no errors in there. Yeah, that RAM's passing all right. So it definitely was that RAM expansion. So it's like, well, oh, there we go, it's failed again, look, on a different bit. So, that is really blooming weird. So the first thing I'm thinking here is maybe one of these RAM chips has got green pins or something again. Let's use the extractor here, it should be easy to get these out with it. Right, so the problem there, and it took me a long time to work it out actually, like 15 minutes or so. I swapped the RAMs, you can see I've removed one of the RAMs here, put a different one, and I retested and I kept moving that RAM around. And at the same time I was using this contact cleaner. It's not normal WD-40, it's not solvent, it's actually contact cleaner. And it got a bit better with each chip, until eventually, after cleaning all 4 sockets, it's working fine. So yeah, I think what it is, just looking at those sockets, I think I cleaned up and reinstalled the original sockets, and there was just a little bit of greenness around them. So yeah, that's a good tip for you. If you do fix a RAM board, don't be tempted to just fit the original sockets, even though they may look okay, just replace them. I'm sure that's what it was. I think for just for good measure, I think I'll clean the actual slots where it joins there as well, actually. And of course, if you move the one around as you test, if you've got 2 chips faulty, that's not going to help you, is it? Ideally you want 4 known good working chips and then introduce one at a time the bad ones. But anyway, that's that. Let's just take this out. As I say, it's been through the ultrasonic this, but you know, there was some corrosion. You can see there's a bit of fluff there actually, some dust. But with the intense heat in the UK over the last few days, it wouldn't surprise me if you know, it just, you know, a bit of corrosion on there just sort of got going or something somewhere. But anyway, I'll just leave that a minute for that to evaporate a little bit. So I'll let that go around for a while now, I think, and then we'll do the serial parallel ports and stuff. Just make sure those are okay. Well, I stand corrected, it's actually this RAM board. It's the RAM board. Swapped over another RAM board. This one, after swapping the RAM chips around a few times, cleaning the sockets, putting the RAM back in, I was then getting a constant yellow screen. I removed the chips, put them back in, yellow screen. Cleaned up the PCB, dried it off, put all the chips back in, yellow screen. Constant yellow screen, changed of all 4 chips, yellow screen. So there's something going on with this board. I don't know, one of the sockets, obviously, I think, is in need of replacement. And as you can see there, yellow screen. Yeah, so that right hand side there is 5 volts. You just need to be careful not to short to ground. I'm just going to go around this RAM, just see if we get any floating connections anywhere. Yeah, so it would appear the pin's down here. I haven't said that one's the same. Maybe there's a broken trace. Because like that one there, pulsing. But then here, there's like nothing. Nothing. On these end, oh, there is there then. Right, a really simple fix. 44256 pin out. I'll overlay this on the screen. So this is the VCC pin, 5 volts, yeah. Those 2 chips are joined. That one's joined. This one isn't. It's missing 5V on that corner pin, and the pin next to it is one of the address lines, so joins to that one, joins to that one, doesn't join to this one. So it's just these 2 pins here, which is opposite what I thought. I was probing, I was seeing weird stuff down here, but if we'd measured the 5V there, that would be dead obvious, and no power to that. So those 2 pins, I just need to join to that one there. So it's going to be these 2 pins on the end, just put 2 wires up there. So I'll report back in a minute when I've done that, and we'll go and test it again. So the traces were okay, actually. You can see I've removed the socket just using the engineer to solder pump here. Set you back about £10–15 that. Can you see? Dirty. So I'll clean up the pads here with the fiberglass pen, get a new socket on, and hopefully that should bring this back to life. So I've got a brand new dip socket there. Yeah, that old one will go in the bin. I'm not even going to rework that. It's just too gone in terms of corrosion. But if we just clean up around there, and obviously you need to inspect those pads and traces to make sure they're alright, but I'm sure they are. See, when I originally repaired this, replaced that socket because it's near, and I thought these 2 were alright. Well, clearly this one isn't. The one up there is, but again, it's probably a good idea just replace it. So I don't know, I might revisit this at some point and replace the other one. Yeah, so the pads and traces there are fine. Pin 1 towards the left here. Yeah, it's about as good as I'm going to get it, I think. Let's go and try it. Yeah, so that RAM board, very interesting. You'll see here this is my other R6. This is one, I'll stick a link up there, fixed it in a previous video. A number of times, I think there are a few fixes to this one. But this board, yeah, in the previous A500 you saw, does come up with those failures. It fails, and it fails within, I don't know, past 2, 3 or 4 of the memory test. And you swap for any other RAM board, and they all work, yeah? The connections are perfectly clean. It fits really well, yeah? But you take this board out and I'll put it in here or any other 500 and it works perfectly. There are no errors at all. So it's a mystery. There's something timing related on that other R6A, because this is a 6A, but maybe, you know, it's a different colour. Maybe there's a different modification somewhere, something clock related or an extra cap somewhere. There's some difference, because I've ruled out all the chips. You'll remember that the purpose of me testing that board originally was to test that chips, you know, the chipset. And I reverted one by one the chips. Gary, you know, Agnes, the CAAs, everything. And the RAM fault was still blooming there with this board. So, I don't know, there might be a follow-on of that. Have you ever found one of these A500 RAM boards that doesn't work with one particular A500, but it works with all the others? Because that's the first time I ever seen that. Post in the comments down below. And you can see that here, it's been running for about, I don't know, 15–20 minutes or something. We're up to round 71, yeah? On that other board, the one that was giving the RAM errors, with any of the RAM board, in fact, the RAM board left on there, I left that going, and it was up to like 300 and odd passes without an issue. You take that board out, put this one back in, and within 2 or 3 passes it would error, yeah? In one of the same 3 bits, bit 5, bit 8, I think, or bit 1, every single time. So, I don't know, maybe there's a fault on that. We might revisit it, it might be a repair. So I am actually just sticking some of the stuff on here now, and things that don't make sense. You'll see this, I always do this, like sticking this socket here, I pinned it down, but it makes sense to do that after you've done this. So this is pinned down with 2 connections as well. It makes sense to get these things here in place, but it'll be no problem. I'll get a piece of captain tape down there and I'll just carefully drag solder, and that IC will be no problem. These will be okay with tweezers, jumper no problem. This one down here a bit tight, but again, I can do that, there's enough clearance there. So yeah, like those are soldered on entirely, these are all soldered on entirely. I've done the decoupling on the underside here, 100 nanofarad caps, and I'm just doing an area at a time because I don't have all of the components. I'm missing a ton of capacitors. I thought I had everything. Missing a ton of capacitors, a ton of inductors, some 7.4 series, that chip there I think I'm missing, a little SMD 7.4 series. It's something like an AS08, I think. I've got the RAM for this. I don't have the chip RAM. Where's the chip RAM? Oh, here. So I need to order that. And I'm running out of sockets already. I've run out of these large ones. I think I've got 2 or so left, which might be enough to do. Up here, I've got 2 there, which I'm going to do a couple of those. But yeah, I'm running out of sockets as well, so I'm going to need to order a load of those. We've got the larger ones here for the gals, so those are bigger than that. Even larger ones to go there. But if you look at an area like this, you see there's very little. You've got an inductor there, an inductor there. a resistor here, so it's easy to fit this stuff, and you've still got clearance. A bit tight there, look, but again, I can do that. I could just stick a piece of Captain tape down there and I can get those little components on without too much of an issue. I may put the finer tip on the iron for some of these. And I think that this is, well, for me, this is the approach I'm taking, because there's so much to go on this. There's so many things I'm missing. If I wait for every component to arrive, I'll be here forever. And likewise, if I just do the SMD stuff, well, I can only do so much of it now, because I've only got, I would say I've got about a third. I've got a third of the components to go on, the SMD ones. Whereas, if you look at the components as a whole, with all the sockets and things like that, connectors, I'm probably over 50% of the components, maybe even 60% of the components, is just sticking caps and inductors on. And 10274 series again, look, there's another one there, so I need to order one of those, whatever that is. Yeah, so that's pinned on, this is pinned on, that one there is pinned on, I think that's it. Oh, this one here is pinned on as well. So I've got 1, 2, 3, 4 things here I can solder on. I am going to do that, because I know I can work around the gaps around them.